Okay, I don't know if we're going to get through all of this today because this is sort of a long PowerPoint presentation. And I want to say hello to all my YouTube watchers out there. This is the Duramax, what it looks like right here. All right. Now, diesel fuel injection requires high pressure, getting the job done, intense hydraulic pressure, springs, pockets, check valves, small orifices. So it's all about what happens at the tip of the nozzle. You look at those nozzles, it's hard to even see the hole in the tip of that nozzle. Diesel engine responds to the delivery of anything it can use as fuel, including motor oil, but performance, engine life, and economy depend on fuel quality and precise delivery. So increased precision and fuel control is what electronic diesels are about. They're more emission friendly, they do the same job in a whole new way. Of course, this has been around for a while now. This is a Duramax fuel system. This is what it looks like. Now, see these right here, your common rails. There's your injector. Those things are made by Bosch. And you got your fuel injector control module and your engine control module. This one right here uses some transformers in there. Some capacitors rather. I keep thinking power stroke. To step the voltage up to 93 volts. That's what operates your injectors. And this right here is the high pressure pump that feeds the common rail. Now you might notice there is no low pressure fuel pump on this. There's a little low pressure pump and a high pressure pump that has to pull the fuel out of there. And it creates about 9 inches of vacuum or something like that. I've never liked that. The return system is in light blue. There's actually a junction block here with a pressure limiting valve that ties all this stuff together. And so the injector control module is the electronic muscle used by the PCM to operate the injectors. Kind of what it is. I didn't have perfect pictures on all of this, but we're going to do what we can with it. It only does what the PCM tells it to. It doesn't do any thinking on its own. Okay. Now then, you got your high pressure pump. It's a positive displacement gear driven radial piston design. Contains the spur gear pump that brings fuel from the tank. Now this is the early Duramax that I'm talking about. Alright, so you basically have electric transfer pump. Now this is an interesting thing. On units with dual tanks, the engine controller uses the electric transfer pump to transfer fuel from the auxiliary tank to the primary fuel tank when the primary tank runs low on fuel. So it automatically just transfers fuel from one tank to another. See, that's something that the driver doesn't even have to worry about on the ones that have that. The fuel rail is mounted on each cylinder head, and each fuel rail has 16 cubic centimeters of fuel to provide constant volume and dampen the oscillations as the injectors operate. Okay, come on. The injectors are operated by the fuel injector control module, and basically below 2,500 RPM, an electronically triggered split shot injection strategy is used. It starts a squirt to fire light the fire, and then it puts another squirt in behind it. That's something they basically were doing on a lot of them. The old Caterpillar injectors that Power Stroke used had a mechanical way of doing this. The 6-liter has got 2 solenoids and a spool valve, and it kind of was trying to do it all that way. We'll turn that back on. But they had trouble with that. And so whenever they took the split shot out of it, because funky idle problems early on, it caused the fuel economy to go to pot. So anyway, and you couldn't walk that back either. There's your filter separator. Now this thing right here is a pump where you got to pump it to fill up the, to get the air out of the rail and all that kind of stuff. It's got a heater, water and a fuel lamp sensor, and a priming pump. Priming pump on top. That's a Bosch thing. They always like that. The old Volkswagen diesels I worked on used to have those. The fuel heater operates below 40 degrees Fahrenheit. So be aware of that. Okay, so the filter should be changed every 15,000 miles. More so if you're running contaminated fuel. Here's your high pressure fuel system. And there's a sort of a black and white picture of the pump right there. And I didn't know a really good one that I put on there. The high pressure and supply pumps are combined in one unit. And this is kind of how they work. The lift pump, got an inlet here and an outlet there. It's got little gears in there. That creates the vacuum that pulls the fuel up there. Then you got your high pressure pump. It's got these 3 positive displacement pistons and all that. So your fuel rail pressure regulator is there, and a distinct difference between the Duramax and the Power Stroke is whenever you unplug the this regulator on the Power Strokes, they like to go to the bottom, the lowest pressure, which typically causes a no start. You unplug that on a Duramax, it goes the other way. And that's what GM kind of likes to do, even on their GDI stuff. A lot of the times when you unplug a DGI on a GM, it maxes out. All right, now while the pump is gear driven, like older injector pumps, there's no timing mark. You just put that thing on there because the timing's done by the engine control. All right, so there's your little pump there. We'll see if we can pull it out. Integrated fuel pump, fuel rail pressure regulator, there it is. And there's your little rail pressure regulator, fuel in, fuel out, so on and so forth. The PCM control with a duty cycle ranging from 5 to 95%, and the old power strokes I was used to would be like from 0 to 65% or something like that. They didn't ever get as high as 95%. All right, so your duty cycle range at 5%, notice that's like it was, if you unplugged it like that, 23,200 pounds is actually 23,250 is what I read somewhere else. And then at 95% is 5,000 pounds. That's how much fuel pressure is in those rails. Okay, so electrically disconnecting the regulator will drive it all the way to the top. What are we talking about? A pressure relief valve in the junction block bounces to regulate the pressure mechanically when that kind of thing happens. There's your junction block right there. That's a cartoony picture of it. But I've got high pressure in purple. See, and a low pressure return in green and that kind of thing. All right, so here's your pressure limiting valve in your junction block. Your fuel rail pressure sensor is right there. That's how it knows what the pressure is in the fuel rails. You got high pressure coming in, you got low pressure going, that's return back there. I'm trying to color code it. And there's your pressure relief valve. That's what it looks like actually on there. And then you got your fuel rail pressure sensor on that picture right there. The fuel rail pressure sensor is a pressure sensitive transducer mounted in the junction box. And whenever it's got these little soft iron seating surface, if you ever take it out of there, you just put a new one on it. You don't take this one out and put it back. Connector terminals, you got an amplifier circuit and sensing element. It evaluates, processes, and strengthens the output from the sensing element so that it'll be able to send a signal the engine controller can use. Like most other 3-wire sensors, it's got 5 volts, a signal return wire, and a fuel rail pressure signal feed. The fuel rail pressure relief valve is mounted in the junction block. It pushes against that spring when there's enough pressure to make it happen, and that goes out to your return. Limits maximum high pressure to 27,550 because it is a positive displacement pump and it can bust something. All right, there's your fuel rails. Each rail is common to all the cylinders on that bank. That's the name common rails. The rails contain 16 cubic centimeters of fuel and dampen oscillations. I mentioned that earlier. And the electronically controlled injectors are installed in the center of each combustion chamber. Fuel is injected directly into the cylinder. That's kind of a cutaway of what they look like. It's got that from GM. All right, and they're driven by 93 volts produced by capacitors. And I said and step-up transformers, but it's primarily just capacitors on that. Step-up transformers are what Ford uses, and GM likes to use capacitors. So the low-pressure fuel system works like this. That's kind of what it looks right there. There's your return lines there on the low-pressure fuel system. The return system must be free-flowing. If anything's blocking it, you're going to have issues. They should never be routed to flow uphill. Whenever they're coming, they always need to be going downhill. Really important. The fuel cooler is like a little radiator. It's mounted kind of back there under the truck. It's mounted in a perfect place to get clogged up with mud. I thought that was just absolutely brilliant for it to do that. I mean, it catches air, but it catches a lot of mud too. Okay, so it's located in the return line near the fuel tank back there. And you got to check it for clogged fins. It's a good idea to clean that thing out when you're doing a service on a Duramax. Now the newer Duramaxes may be different. All right, so the ECM inputs, you basically got all of this stuff going in there. Injectors to class 2 data to scan tool, and then you got your CAN data to the fuel injector control module. That's they want the CAN data because of the speed necessary, and CAN is a lot faster than class 2. And so basically you got your ECM output, your fuel rail pressure regulator, they got injector commands, crank angle, that kind of thing. And there you go, your ECM and fuel injector control module communicate on a CAN bus data link. You got a J1939 controller area network link, and you see all of this stuff here. You got your glow plugs, intake heater, cruise, transmission control module, Pernal stick, cam position, crank position, all of that stuff is hooked up in there. This right here gets its marching orders to there. Scan tool data and communication with other controllers is carried out on a class 2 data line. All right, so here we go. The controller area network is the 1939 250,000 baud rate. And that's an interesting little thing. Faults are reported by the ECM and to the ECM by the fuel injector control module. And that's GM's wiring schematic of that. And so basically that's the way that kind of thing works. And here we got it doesn't store trouble codes on these older ones. Like I say, the newer ones may be different, but this is the earlier Duramax that I'm talking about here. Monitors the fuel injector control module via the CAN bus, and it interprets reported failure, stores trouble codes, and illuminates the mill light. And there's basically looking at your fuel injector control module. It's basically connected to the injectors, and the engine controller is what tells it what to do. The appropriate commands are sent to the fuel injector control module whenever it sees something that's needed, and that operates the injector solenoid with 93 volts. The way the injectors work is whenever they move a little poppet off the seat down there and let the fuel go through, and then pop them like a regular injector. On the Ford, the common rail, they basically have a piezoelectric thing. You put voltage into the piezoelectric Ford injectors. That center part of that injector, piezo part of it, contracts 1/1000th of an inch, and that's all you need to do on that in order to make it put the fuel out there and pop that injector. Creates the current based on crank position signals and ECM requests. And so basically it's internal capacitors are recharged using the 50-volt spikes generated by each injector coil as it's de-energized. You remember the spike I just showed you on the scope earlier? That spike's what I'm talking about. Well, of course, like I say, you're using 93 volts. All right, so each injector driver in the fuel injector control module has its own hardwired signal feed from the engine control module. All right, so the fuel injector control module generates heat while operating, mounted in such a way it's cooled by the incoming fuel. So the fuel goes right by this thing and cools it off because it gets mighty hot. Well, the old ignition modules are kind of like we think about. We used to put the dielectric grease between that and the distributor on the Fords and on some of the other heat sink stuff and all that. All right, so basically this is sort of like your little, I like to call these Bart Simpson heads. It takes more current to open it than it does to keep it open. And this is a cool little thing. You got a solenoid valve on it. You got your acceleration, pull current, unloading, holding current. See, it's holding it open the whole time there, but it takes a little bit more to pull it up there. It's kind of like, imagine this, whenever you stop at a traffic signal on your vehicle, whenever you take off, there's more load on the powertrain taking off than there is driving. And it's kind of like this. Once it opens it, it doesn't take as much to keep it open. So you can see the amperage change on there. Okay, so current control circuits built into the fuel injector control module divides injection time into a pull current phase and a holding current phase. So it's a smart box, really. All right. Opening the injector, it takes 18 amps, but 12 amps will hold it open for the duration of the pulse. And some ECM generated codes related to the fuel injector control module are these. PO612 would be the relay, PO201 to 208 your injectors. Be aware of this, these 200 series codes are injector related. And then your 1261 and 1262 would be open bank 1 or open bank 2. All right. So basically, the way that operates here, you got these drivers here. Yeah.
Trying to pick up the keys.
Oh, they're in it?
Oh, they're in it? Okay, thank you.
Yes, ma'am. All right, the high side drivers, one for each bank, deliver high voltage to the B plus side of the injectors. There's your high side driver there. There's your engine controller. There's your fuel injector. See that these basically go through there, and it basically is what tells the fuel injector control module to do that. All right, and then the low side drivers provide ground signal to one injector. So basically, you got B plus, and then you got your low side. All right, so that's not too complicated. The ECM monitors individual injector current draw via CAN bus communication from the fuel injector control module, and they're divided electronically as shown here. Group 1 is 1 and 7, 4 and 6, and then group 2 is 2 and 8, and 3 and 5. Fire in order 1, 2, 7, 8, 4, 5, 6, 3. You'll have to memorize that. It will be on a pop test when you come back from spring break. All right, so this right here, if a high side short or open occurs for 32 milliseconds on group 1, a P1261 code set, group 1 is then shut down and fuel delivery on group 2 is increased. So it will actually shut one bank down, try to operate it on the other one. Sounds to me like they're thinking kind of like the Ford folks when they did that. P201 to 208 codes indicate individual injector circuit problem. That's not complicated, it's not hard to figure out. All right, if a PO2XX series code set and the RPM won't stabilize, the entire injector bank in that group will be shut down. The ECT sensor is a negative temperature coefficient sensor that operates in conjunction with the voltage divider circuit in the fuel in the ECM. This is not new. GM has been doing this for a long time, and so has Chrysler. Basically what happens if you're watching it on a graph, you'll see it do this. You'll see it pull that voltage down, pull it down, and then it jumps up and it pulls it down again. That'll make you think there's a problem, and it's kind of like it shifts gears so that it basically has a resolution that it can use to determine temperature. If it just kept going down to where it was really low, it would have a lot of trouble reading from here to here. But because it shifts gears, it's basically got a high resolution signal going down there. All right, the mass airflow sensor measures airflow and density depending on ambient temperature and engine speed and load conditions. We're going through this really fast. All right, here's your mass airflow sensor. Engine 1 fuse, 10-amp fuse, feeds the mass airflow intake air temperature sensor. And basically, these are the color wires and all that you're going to have on that. The engine controller uses the vehicle speed signal to control transmission function, cruise control, and some fueling modifications. All right, the manual and four-wheel low series transmissions use a hardwired sensor, but the Allison transmission controller communicates vehicle speed on a class 2 signal line. So some of them get it directly, some of them get it through the network. Basically how that works. There's your boost sensor. Monitors turbo boost pressure and is mounted on the intake manifold. And there's your boost sensor, what it looks like right there. You know, you got as far as your schematic of it, boost signal, low reference 5 volt. That's old hat. We've seen a lot of that kind of thing. There's your accelerator pedal position sensor. 3 redundant potentiometers are used. That's 3/4 of a volt, 4.29, 4.29 to 2.98, 3.98, 3.20. Almost looks random, doesn't it? All right. And let's see, accelerator pedal position sensor there. You're going to have, let's see, there it is down there. If one sensor fails, a diagnostic trouble code will be stored. Engine operation will be normal. If you lost that one, you can still depend on the 2 other ones that are left. If 2 of them fail, a DTC will be stored and the engine power will be reduced. And if all 3 of them fail, it'll store it and it'll just won't operate above an idle. So basically it won't do anything on that. So there's your crank position sensor. It goes into the side of that housing. That's what it looks like on the truck. All right, and so that's what basically you're looking at right here. You've seen crank sensors before. Nothing all that special about that. It uses it to input crankshaft position and monitor misfires. You notice that little missing thing? Like you basically, you're going to have on these diesels, they have a lot different setup. They'll have like a 60 - 2 on the power stroke and a 60 - 3 on this one, as I remember. Okay, so yeah, that's 60 - 3. You've got 57 teeth on there, and there's 3 teeth missing, but on the power stroke there's only 2 teeth missing, which is a kind of an interesting thing right there. There's your cam sensor. That's what it looks like. It looks similar to the crank sensor. And it's not really such a big deal either. You basically got to have I mean, you can actually get a scope pattern on this, but it uses cam position. Now listen to this. That's interesting. Only during engine cranking to determine injector firing order. See that? That cool? Or what? I mean, some of that stuff you probably wouldn't know. And that's what the little pulse ring looks like on that. There's your cam sensor reluctor, goes on the front of the shaft. There's your fuel rail pressure sensor. Got return pressure, high pressure, fuel rail pressure. Every closed loop system needs a feedback sensor, and that's what this sensor does. All right, and so there you get to the little soft iron seat. We're looking at that again, a little closer. Sensing element, evaluation circuit, soft iron seat. Remember, if you take it out, you got to put a new one in. Signal produced by the sensing elements amplified by the evaluation circuit. Sent to the engine controller. There's your codes, PO192, PO193, high and low voltage. Remember those 2. They will be on the test. In the case of a fuel rail pressure sensor failure, it limits engine RPM to 200 RPM with a fixed fuel rail pressure strategy or a limp in. All right. This right here is your fuel rail pressure regulator. This is what actually causes this is the actuator that it uses to control the pressure. And so it's basically you get your windings right here, you get your wires going in, you know, that opens and closes, you got your inlet and outlet, and it dithers that and all. Based on that, from 5 to 95%. And remember, we gave those numbers earlier. Don't need to really go over that again. A disconnected solenoid will make it go really high. Talked about that too. A shorted control circuit is an extreme low pressure and a probable no start because you're not going to have enough pressure if it's shorted. Fuel rail pressure regulator related diagnostic trouble codes, PO88, 87, 89, 93, 94. Control circuit, small leak, large leak, performance. See all that stuff that you can get out of there? All right, that's basically what you're looking at. You got a purple white wire, and you got a yellow wire. Control circuit, 12-volt supply. Okay, there's your injectors right there. We're going to talk a little bit about those now. There's 1, 4, 6, 7. See how they're spread apart on these two banks right here, like I showed you earlier. All right, and let's see what we can do here about putting something up there. Engine control module, goes to fuel injector control. See, coming from there, your fuel injector control module is going to receive its marching orders for its drivers in there. And obviously it's fused injection B fuse 25 amp from the junction block under the hood. And there's your fuel injector control module. Basically both of these are the same box, but in order to draw it so you can understand it, you might notice you got voltage going here, and then you got your command going down there. 93 volt injector solenoid require 18 amps of pickup voltage. We talked about that earlier. 12 amps after it's open. And if the fuel injector control module does not receive a crank signal, but does receive injection request from the engine controller, a PO 370 or a 374 will be set. Remember those two. Injector fault, circuit faults will set 201 to 208. We talked about that earlier. 1223, 1226, 1229, 1232, 1235, 1238, 1241, or 1244, meaning the ECM has determined the commanded output and the state of the driver don't match. So it's watching all the time. It does this and it sees what's happening. So coolant temperature and intake air temp are monitored to determine glow plug operation and on time. And then funky little glow plug down there, you see. And then the glow plugs stay on for 30 seconds after engine start. They stay on, well look at that, that's nice, I did that twice, right? Okay, glow plug and intake heater relay assembly. See these right here, you gotta recognize these are glow plugs and not injectors, that's what those right there are. Okay, now the cool thing, there's some differences here. The California glow plug system is required to monitor the resistance of each individual glow plug. There may be some other states that are requiring that now too. And that's what they look like there. I mean, you see that little symbol right there, that's a heater when you see that. Now they didn't show that way in the other one. A schematic symbol of a heater is that funky little thing there. And there's your 175 amp fuse, and then you got that fuse, and here's your glow plug controller. See? And that's California only, that's a different deal. So you can notice it's got a little bit more stuff. Now the intake air heater on a Duramax works different from the one on the Power Stroke. What we got here, that's what the intake air heater looks like. Did you know that was the intake air heater? You've seen that before, right? There's that, that big old hose. Y'all had one that was blowing the hoses off the other day or something you said when you was driving.
Yeah, somebody put a delete kit on it and didn't do it right.
Yeah. Yeah, we see that a lot. Okay, basically your heater relay, this is not complicated. See the little heater control, heater monitor, got a, running your B+, that's not complicated at all. However, it's activated as needed by the engine controller and stays on for 180 seconds at a time. So anytime it needs to heat the intake air, it'll heat it. Now on the Power Stroke, it uses it when you first start it up to keep it from having white smoke, but beyond that, you're not going to have it, it won't work after a certain amount of time. When you first start it, it's when it operates out. And the heaters are basically the same. They pull about 50 amps, I think, if I remember right. Okay, but anyway, there's your EGR system. And that's how that works. This is really interesting to me because EGR valve solenoid, you got a vent solenoid, and you got what we call ERK and ERV, whenever Ford was doing it. That's controlled by the way of old-fashioned vacuum vent solenoids on these older Duramaxes. And so now the Ford was went electronic, Anyway, some of the newer Duramaxes actually use electronic EGR. But anyway, that was just sort of fun right there. There's the ECU works the EGR vacuum control and vent solenoids together on the older Duramaxes, and they added another solenoid, which is your throttle valve solenoid. What was the throttle valve for? Why in the world you need a throttle valve on a diesel? Think about that. It's going to close the throttle valve to cause low pressure so that EGR will work. See, you got high pressure on your EGR, and if you've got a turbo, and the turbo is shoving a bunch of air in there. If you don't have a throttle plate, you can't get any EGR. Now there's ways around that. I mean, they kind of got away from that later on, but that's what they did that. So since a diesel produces no vacuum, the throttle body's got that ECM control throttle plate on these, and there's a vacuum sensor there. So it wants to know how much vacuum it's creating as it starts to close that throttle plate. Now your Power Strokes, early Power Strokes had that too. But in '05, they did away with it and they just made it, draw it in, by putting a little flute there. The ECM needs to know how much vacuum is being created. And there's your vacuum sensors for that point whenever it's got these. Now, like I say, these are the older ones. This doesn't apply to all of them. All right, so inputs affecting EGR operation are these. Accelerator pedal, barometric pressure, boost, engine coolant, EGR, IAT, mass airflow, vehicle speed, and engine speed. That's what the old EGR looked like. Now here's a few diagnostic tips. Real-time or live data, freeze frame data, and snapshot recordings. All right, a PO087, fuel rail pressure too low. PO0088, fuel rail pressure too high, greater than 175 MPa. All right. So basically, you got all of these right here. We could talk about codes. Just these are the ones that can trigger limp in mode: 88, 90, 93, 94, and then 192 and 93. Use the boost pressure parameter to determine manifold pressure. You can actually look on your scan tool and determine what it is. Verify the customer complaint. Common sense quick checks. Check gauges, check filter minder, check crankcase oil. That's the obvious things that everybody ought to do instead of going after the problem before you check the basics. Supply vacuum, high pressure, return flow. All right, you check for diagnostic trouble codes, check component DTC'S first, and then check system DTC'S. And then look for technical service bulletins. Always look for technical service bulletins because you'd be surprised how many of them there are out there that will help you. Learn the diagnostic trouble code, use the diagnostics, and it's still a diesel. Now the fuel delivery is different, but it's still doing the same job. It's using diesel fuel to do it. Determine the cause. Every component has a job to do. Is the component doing its job? Are the necessary inputs in range, or are they out of range? Try to duplicate the concern. Gather data under the same conditions described by the customer. 45 miles an hour uphill on the way to church. Learn as quickly as possible what normal data stream numbers look like. Find a scan tool. Hook up to one of anything you can hook up to and look. Now look at this. Engine speed, 653 RPM. What is this right here? What is that reading? What would you call that?
It looks like millimeters to the third.
Exactly right. That's cubic millimeters. That's what that is. And this is the way these diesels figure it. It's cubic millimeters of fuel. Actual fuel rail pressure, and then you got fuel rail pressure command. It gives you that. Main injection timing, 4 degrees. And then you got this right here. You can see how that looks. Calculated fuel rate, 12 mil, and pilot injection rate is the first part of that double squirt. All right, now you got fuel system engine speed, 3396. You notice that this is going up, and your fuel rail pressure is going up. Your fuel rail regulator command is going up. Your main injection time is changing. Indicated angle is 100%. We're wide open throttle. Fuel rail temperature, 84 degrees. That's an important PID. And then your pilot injection remained the same, but this one here didn't. All right, so check for fuel supply restriction using a vacuum gauge. GM tool number is J44 638. And basically, remember I told you it has to suck it out of the tank. You got a restriction back there, you got issues. 5 inches of vacuum, normal. 5 to 10, replace filter. 15 vacuum, performance suffers. Greater than 20 inches of vacuum, it shuts the engine down. Duramax fuel pressure does not normally hold steady at engine shutdown. It goes away. Fuel system diagnosis, the pressure regulator sensor failure, low power, poor fuel economy, misfire, and so on. Junction block pressure relief valve stuck open, engine usually won't start because you won't have any pressure. Can't put any up there. Hunt and idle at 90 RPM fluctuation. Let's see what we got here. Diagnostic trouble codes 88, 89, and 90. Data stream check. It's going to come up, I think, by itself. Or will it? Hunt and idle. Visual inspection, okay. All right, here we go. That's an actual scan tool there. 600 RPM. Actual fuel rail pressure, look at that, 23,090. That is really, really high. Desired fuel rail pressure, 4390. Do you see a problem?
Yeah.
All right, the more you put here, the lower that's supposed to go. So this has got this way up close to 95%, trying to make this come in line with that. Fuel temperature censored 166 degrees. Calculated fuel rate 16 cubic millimeters. Pilot injection fuel rate, and that's just under there. See how that's so small now? And the main injection fuel rate is 13.8 cubic millimeters, and so on and so forth. Stalls and restarts, knocking noise, mill on. You got all these DTC'S right here. Remember, a shorted or open circuit, even on one injector, will cause the whole bank to be shut down if the RPM doesn't stabilize. Don't attempt repairs on the 93 volt side of the engine controller as much as you'd like to. And don't use a hammer on the wire harness, okay? All right, loss of power on long trips, that's sample diagnosis number 2. You do the data stream check here, and you look at what you got here. Fuel temperature sensor is 186, engine coolant sensor 152.